Hey there, I'm Lucia from Confluent. Have you ever wondered how to build a dashboard with live data? I got you. In this video, I'm going to show you how to do that using Streamlit, the Confluent Kafka client, and Flink SQL in Confluent Cloud. Let's go. Let's get started with creating an environment in Confluent Cloud. We'll add a cloud environment and name it Stocks Environment, then create it. Now, let's add a cluster. We'll make sure to note which provider and location we use for this step. We'll name it Stocks Cluster, then launch it. We need to create some credentials now so we can authenticate from our client. I have more than one environment, so I'll go to my Environments page, select my cluster, and select API keys under Cluster Overview. Then I'll click Add Key and copy it to a secure location. I'll enter a description of the key and click Continue. We'll create a topic, name it after the stock we want to eventually display in Streamlit, and change the partitions field from 6 to 1 before creating with defaults. This will make it easier to consume our records for the purpose of this demo. In production, we'd use more partitions. We'd like to define the shape of our messages, and a schema registry will enable us to do that, so we need to set up separate credentials for it. In our environment, we'll click Credentials and add a key here for the schema. We'll click Continue after saving our key and secret. We need to set a schema for our topic, SPY, the name of the topic we'll be tracking. Once I have the schema editor up, I'll enter my custom JSON schema. We will create the Flink compute pool next. Under Flink in our Environments page, we'll click Compute Pools and create a compute pool with the same region as our Kafka cluster. We'll rename it Stocks Compute Pool, and we'll make sure that we have 10 CFUs. We'll then click Create. It might take a few minutes for our pool to enter the running state. Now we can start running Flink SQL statements in the cell of our new workspace. We'll create a Flink table with fields indicating the end and start of a window and a price for each end and start, and click Run. By the way, this also generates the Kafka topic we'll consume from. We can verify this by visiting the Topics tab and seeing the created topic. We'll need to run an insert statement as well. We'll click the plus symbol to add a statement in the workspace. Every 5 seconds, it takes the average for the SPY stock price and adds it to the tumble interval SPY table. Note that no data will show up in these Kafka topics or Flink tables until we run the app. We'll need to sign up for Alpaca to get a key. Then we'll navigate to the Alpaca homepage. Note that we do not have to give a tax ID or fill out the other account info to get your paper trading key. Now we'll generate a key using the widget you'll find on the right of the screen on the homepage. This is the key and secret you'll be adding to the app. Let's clone the app and install the requirements. Now we create a file in the root directory named .streamlit/secrets.toml, which is where we'll store all the credentials we've collected from Confluent Cloud and Alpaca. Now, run the command streamlit run app.py in your root directory in order to run the app. Let's take a look at the behavior of the app on the homepage. When I select SPY, we can see the stock prices being analyzed in a live line chart. This is cool, but how does it work? Let's look at the code. This is the function that's called from Streamlit when the user selects the stock to view. The Alpaca websocket subscribes to the stock and runs. Take note of the partial function. We're passing in the stock name, which will help us configure the producer's topic, and a special function that handles the incoming quotes when the Alpaca client subscribes to the quotes. Here, we're setting up the configuration for our schema registry, initializing the client, setting up the serializer, and producing the stock information as a message to our Kafka topic. That's being processed in Confluent Cloud with Flink SQL, and a Kafka topic created to hold the processed data. Now, how we're getting the data out of that topic? That's the role of our consumer client. I've truncated the code here for readability. Let's walk through the significant bits. We subscribe to the topic we'll consume from. Next, we poll the consumer. Then we take in the message from the consumer. We parse out the last price as well as the end of the window. Then we add each price to a list of prices and add each window end to a similar list. Then we declare our pandas data frame, as well as our domain end and domain start. Lastly, we declare our Streamlit chart component, which will be a line chart with the window end values on the x-axis and the pricing on the y-axis, with the max and min of our domain end and beginning. To save on resources, you can delete the environment after running through this exercise. We could do it in the user interface, but I'll show you another way using the Confluent command line interface. Find the environment ID with this command. Then run this command to delete the environment and its associated resources. If you're curious about Flink SQL or Kafka, visit the links below to learn more about how to use these data streaming technologies. If you have any questions, leave a comment below, and I'll do my best to get back to you. Thanks for watching, and see you next time.